What about trig functions? Well, same rules apply. We look at the domain. If we think about the domain of sine, what can we put into the sine function? Is there anything we cannot put in there? Well, we don't have a fraction there. We don't have a square root there. We don't have a natural log. So this is continuous, again, for all reals. And think about it this way. If we were to graph this function, we remember that the graph of the sine curve looks something like this. So it's going up and down, and we just know it continues on and on in this same pattern all the way. And that's another way to look at a graph and determine if it's continuous. The way to think about with a graph is, if I keep graphing this line, do I ever have to pick my pencil up off the paper to start the graph over? The answer is no. As long as I'm graphing, as long as I keep my pencil on the paper, I can continue to graph this line all the way through. So that's what I'll do. I'll graph it all the way through. So that's not an official definition, but if you're thinking about graphing something, if you can graph it, and once you start drawing it, you never have to pick up your pencil, it's continuous for all those numbers. Any place you have to pick up your pencil makes it a point of discontinuity. Find the limit of f as x approaches -3 from the right. From the right. So let's talk about what does it mean to be from the right. Well, that means we're only looking at the limit as x approaches -3 from this side of the square root of 9 minus x squared. First thing we always try is we're going to plug the number in. If we plug -3 in, we get an answer out of 0. Since we got an answer out, this is the limit, and we don't have to do any more to evaluate the limit. But why are we talking about this problem here? Well, let's talk about what this graph would look like. If you were to graph this on your, you would find that this looks like a half circle, a semicircle. This is what you would get for your graph. So why is it important that we only talk about from the right when we're talking about approaching -3? What's true of the function out here at -3.1 or -4? The function's not defined. So we can't talk about the limit to the left of -3, nor can we talk about the limit to the right of +3. We can only talk about the limit at these endpoints from the left side, from the right side for -3, from the left side for +3. And this is where we make an exception in our rules when we talk about continuity. Is the function continuous at -3? We say that yes, it is continuous at -3, even though we can't evaluate the limit from the left side. We can only evaluate from the right. We say that it is continuous because the function stops at that point. So the function is defined, it's approaching that number from one side, and it's not defined after that. Therefore, we say the function is continuous.